خب به ادامه بحث مود شیپ ها بپردازیم. ببینیم که
Mike Plyler. I'm a field application engineer with PCB Piezotronics, and we are a proud alliance partner with National Instruments. And what I'm showing here today is a couple of examples of how easily our products interface with National Instruments hardware and software to give the customer good, reliable data. So what we have here is we have an electrodynamic shaker, which is our smart shaker. It has a built-in amplifier. It's being driven by the National Instruments compact DAC, which is a 9263. We've also got a part of the compact DAC family, the 9233, and we're using that for ICP power and to acquire a signal in a National Instrument-Labview. So, what we have mounted on this beam, on this shaker, we have an accelerometer that we're using for a base accelerometer. Then we've got 3 accelerometers out here on the end of the beam. We're kind of giving a modal shape analysis on this beam. So we've got channel 1, 2, and 3.
شبیه چیزه خطکشای فلزی هستش که توی لوازم تحریری رو میفروشن. در واقع مثل
And we're using a LabView, and we've got our base here and our channel 1, 2, and 3. And we're also using LabView in this demonstration over here where we've got a brand new product that we've just come out with, which is our Digiducer. So the Digiducer is kind of unique in the vibration industry. It's an accelerometer that we actually takes the vibration in and does the digital analysis inside the vibration housing. I mean inside the accelerometer housing. There's nothing like that on the market. So as you can see, what we have is a USB coming into an iPad. This could be an iPhone. It could be a laptop. And we're also shaking it with our portable vibration calibrator. So we're putting a vibration input into the accelerometer and run it here into an iPad. Unique. And again, we are proud to be alliance partners with National Instruments, both in our test and measurement products as well as our industrial products. So, and you can certainly find us, you can look for more information on these products as well as our many other products at www.pcb.com. Thank you.
خب این در واقع حالا بیشتر بحث مکاترونیکیش رو توضیح داد. حالا دلیلش هم این بوده که داشت در واقع اینو میگفت که همین سیستم سینک انرژی رو ما میخوایم پیاده کنیم با استفاده از همین
Ability Solutions Chalk Talk
میتونیم در واقع کارمون رو انجام بدیم. حالا فیلم بعدیمون Understanding Resonance Mode Shape هست. یه نکته بگم، در پایان نامه بحثی از رزونانس نشده، یعنی ما کاری نکردیم که به رزونانس برسیم.
Reliability Solutions presents Key Tips, Techniques, Behaviors, Methodologies. Welcome to Chalk Talk. Hello, and welcome to this week's edition of Chalk Talk. Our subject this week is the subject of resonance. Resonance is a pretty common problem in industry today. Some people estimate about a third of your machines have vibration on them that is being magnified by resonance or natural frequencies. One of the ways we have of identifying a resonance problem is to plot out a resonance mode shape. When structures vibrate due to resonance, they tend to vibrate with a resonant mode shape. There are various resonant mode shapes. For example, if the structure was vibrating like this would be the first critical. The first critical has 2 nodes and 1 antinode. The second critical mode shape looks something like this. In this case, there are 3 nodes.
یعنی رفتاری که سازه از خودش نشون میده، شکل و شمایلی که یک سازه از خودش نشون میده، به این میگه مود شیپ.
And 2 antinodes. Here we have a structure resonating at its second critical mode shape. You'll notice that we have 3 nodal points and 2 antinodes. Remember, with resonance, if we're going to insert a brace, we need to brace it at one of the antinodes. If we brace it at the nodal point, it has little or no effect. If we brace it at either of the antinodes, we solve the problem. So it's not a matter of just making the structure stiffer, it's knowing where to put the brace. Again, if I was to go out into a real structure in the field, I could probably use my coin to actually feel the vibration across the structure, like this. And I could actually feel
سازی پلیت نگاه بکنیم همین رفتار رو
different amplitudes, intensities in that vibration. Now we'll do the third critical mode shape.
حالا شکل مود سوم رو ببینیم.
This has 4 nodes and 3 antinodes. And this one is the third. Here we have the third critical mode shape. Notice there are 1, 2, 3, 4 different nodes and 1, 2, 3 antinodes. Remember, if we brace at a nodal point, it doesn't do any good. If we brace at any of the antinodes, the problem goes away. Of course, my speed varied just a little bit there. So that's resonant mode shapes. In many situations, that mode shape is apparent enough for you to detect it with nothing more complicated than a coin or a screwdriver in your hand. Understanding resonant mode shapes is one of the key elements to understanding resonance. In a later edition of Chalk Talk, we'll talk about how to plot those mode shapes using a vibration instrument and a piece of graph paper.
که باید شما بدونید. حالا اینم باید یه سرچی در موردش انجام بدیم. فیلم بعدی
A 1 degree of freedom mass spring system has one natural frequency and one
در واقع
vibrational
میخواد
mode
برای
shape. The mass oscillates back and forth.
یک درجه آزادیه. دقت بکنید. در واقع یک درجه آزادی بیشتر نداره. فقط تو راستای عمودی داره جابجا میشه. این در واقع شکل مودی که برای یه سازی در نظر گرفته. یه میله که وسطش یه گویی هست. حالا در فاینایت المنت به این گویی ها میگن نود یا گره به فارسی گفته میشه. الان این شده در واقع 2 تا براش نود گذاشتیم یا 2 تا گویی گذاشتیم میشه 2 درجه آزادی. چرا میگیم 2 درجه آزادی؟ اگه من گویی اولی رو سمت راستیه رو جلوی حرکتش رو بگیرم، گویی دومی سمت چپ شروع میکنه به نوسان کردن. یعنی اینا ربطی به هم ندارن، مستقل هستن از هم. حالا بعدیشو ببینید. 3 درجه آزادی سیستم جنفر دمپر. اینا حالا مباحثیه که توی مهندسی خودرو، بحث سیستم تعدیل و شاسی بدنه و اکسل خیلی هستش. حالا اینو ببینید، این 3 درجه آزادی شده. حالا 4 درجه آزادی. ببینید اینها، من یادم رفت بگم، اینا شکل مودهایی که اتفاق میفته. شکل مود اول برای 4 درجه آزادی، برای شکل مود دوم برای 4 درجه آزادی، شکل مود سوم و شکل مود چهارم. بریم ادامه بدیم. این 4 درجه آزادی داره. یعنی چی؟ یعنی من یکی از گویی ها رو بگم، 3 تا گوی بعدی میتونن جابجا بشن. مثلا این شکل مود دومه. شکل مود بعدی رو بریم. یعنی شکل مود بعدیه. این شکل مود بعدیه. فکر کنم شکل مود چهارمیه. خیلی فیلم قشنگی بود. حالا اگه بخواید میتونید توی مباحث بیشتر از این هم تو بحث این وارد دانشگاه پنسیلوانیا بشید اونجا ببینید. حالا اینو ببینید.
Today we'll demonstrate how to run a smart shaker using a smartphone. I have a smartphone running a function generator application and we are running 1 kilohertz through the shaker.
این یه تیریه که از وسط نصف شده.
All the way up to 20 kilohertz and sweep down.
فکر کنم این به صورت آکوستیک داره نوسان، یعنی نیروی ورودی به سیستم آکوستیک هست. ببینید شکل مودها رو یه جورایی میشه دید. اون قله ها و دره هایی که سازه در واقع بخش اعظمی از آنالیز مودال به همین مباحث می‌پردازه.
And I'll go up again. Our resonance at 44. And all the way up to 20 kilohertz. So that concludes our demonstration on how to run a smart shaker using a smartphone.
این شیکره، حالا شیکری که ساخته شده. خب اینو ببینیم. آها، یه بحثی از به اسم ایمپکت همر یا چکش مودال که میزنن به سیستم رو در واقع آنالیز مودال میکنن.
This here is a simply supported beam.
حالا اجازه بدید که من این بحث ایمپکت همر متاسفانه به خاطر ضیق وقت نمیتونیم واردش بشیم، ولی حالا دلیل این که خیلی دوست داشتم ایمپکت همر رو خیلی جزئی‌تر بررسی کنیم تو اون قسمتی بود که بهتون گفتم اکسترنال فورس یا نیروی داخلی یا نیروی خارجی یادتون هست، در واقع پایان نامه هایلایتش کرده بودیم. این بحث ایمپکت همر یا چکش مدال به اونا برمیگرده. ولی به خاطر اینکه وقتی زیادی نداریم و تو جلسه قبل من یه اشاره خیلی تیتروار بهش کردم و همون بسنده میکنیم و همون کافیه، نیاز این سالو بیشتر وارد مباحثش بشیم. اما اینو ببینید، این حالا یه دونه تیری یه سرگیر داره.
Then it is a freedom string. It is a non-contact exciter. This here is a oil damping. It is used for one of the experiments. Oil damper to be precise. This is an impact hammer along with the force sensor attached on it. It comes with the different attachments. We have got steel attachment, rubber attachment. This is used to, see the vibrations when it comes, so you can identify that the natural frequency has occurred. So these beads here, they start shaking or vibrating. This is rotating disc. This is used for another kind of experiment. These here are free weights. This is the motor, and also it is an active isolator. Then coming to the electronics part of the system, here we have two charge amplifiers which are like used for powering one of this impact hammer, which is connected with the channel number 9, and another one is piezoelectric accelerometer, which is connected to the channel number 10. These here are AD channels. They run on voltage input, and this gives the power to the exciter, which is connected here. So in this experiment we won't be needing this part of the system. We are just concerned with these two charge amplifiers, and this is again for USB connection with the laptop. So coming to the software panel, we have got a nice interface. So we can do many kind of experiments on this, like mechanical vibration, simple harmonic motion and all that. But today we'll be just concerned with the first experiment, which is model of simply supported beam. We are going to see the model structure of this simply supported beam. So before starting with the experiment, first I would like to tell you that you got to start the software, and after starting the software, we need to calibrate the parameter settings. You have to do this every time. If you forget to do this, your experiments won't run. Connected with the impact hammer. So we have set the sensitivity, which provides the optimum result. As you can see, it is selected. The simply supported beam multiple times on the different nodes, and each time we hit it, we'll get a response from this accelerometer. So there are different type of experiments which can be done, which you can always refer our theoretical manual for this. Sometimes we can have multiple accelerometers and we can just hit one time, and multiple response can be generated with the help of multiple accelerometers. But today we are just going to see the multi-impact and single response. So I'm going to show parameters here and then click on continue. Okay, so this is the window where our experiment would be conducted. So here you can see the force is depicted with the yellow color, and accelerometer is depicted with the red color. Okay, so I'm going to click on oscilloscope. See, so first you have to see everything is working fine or not. So I'll just hit here on the simply supported beam, and you can see a spike in the red channel, which is for the accelerometer. And if I hit the hammer, then you can see a spike in the yellow. So there is a spike in the yellow one also. Okay, so everything is working fine. So now we have to clear the offset. Okay, once you clear the offset, you can again hit it.
تیم کردن این سیستم رو نشون میده.
So
خب این بعدی رو bending vibration in rotor. این در واقع یک شکل مد در حالت دواره. حالا علیرغم که خیلی ساده است ولی شما میتونید بندینگ رو در پیچش یک شافت ببینید. فرکانس داره هم میری بالا. البته دوره برم و دور داره میاد پایین. جالبه یه پدیده‌ای که ورودیش پیچش هست، دوران هست، بندینگ هم اتفاق افتاده. حالا اینو ببینید، یه سیستم در واقع شکل مدشه برای یک برج 8 طبقه است. سازی برج 8 طبقه. دیدید چه اتفاقی افتاد؟ خیلی مهم توی بررسی رفتار سازه است.
This is a portable sheet table which we are using for demonstrating the three fundamentals in the classroom. Right.
بعدی رو ببینید. این شکل مد این گراف خیلی خیلی به کار اون بیاد. البته درسته که حالا یک ورق دایره‌ای شکل هست ولی شکل مد یک ورق دایره‌ای شکل در اثر آکوستیکه. ببینید در واقع رفتار پیچیده ترکیبی از انواع مدهاست. انواع در واقع حالا میشه که سیریزها در فرکانس‌های مختلف. بعدی رو ببینیم. این شکل مد یک تاره.
Another way to look at resonance is to look at what are called modes of vibration on a string. A mode is just a frequency at which a string, like the one shown here, wants to vibrate naturally in exactly the same way as a simple harmonic oscillator wants to vibrate naturally at some frequency. What we have here is a string that's anchored on one end. On the right-hand side, you can see it's tied onto a clamp that's clamped to the table. And on the other end, I've attached it to what used to be a perfectly good mid-range driver and now won't work very well ever again. We'll see in a minute. I'll zoom in on some of the details here to see how this thing is going to work. But the idea is that we're going to use the mid-range to inject energy into the string. We're going to move it at different frequencies and see what happens. See how the string behaves if we move it at a very specific and a well-chosen in advance frequency to see if we can force it into behaving as it normally would when it's ringing at one of its modes of vibration. So you can see here, this is a close-up of what I've done to that poor mid-range. I've glued a post, in fact it's just a wood screw, onto the dust cap of the mid-range, and I glued some small sticks on there to keep it upright because the string is pulling it sideways a little bit. What we're going to do is move that driver, the loudspeaker, up and down, and that's going to, of course, move the string up and down, as we'll see now. So here we can see what's happening. I'm driving the loudspeaker with an amplifier attached to an oscillator. The volume of the amplifier determines the amplitude, so how much the woofer is moving up and down, and the oscillator I then use to determine the frequency, which is how many times per second it moves up and down. And as you saw a minute ago, the other side of the spring is attached to a clamp. I can change the frequency. This is about 5 hertz going up to, this is something like 10 hertz, 9 hertz or so. So 9 times per second, going to 8, 9 hertz. And suddenly you'll see when we hit 11 hertz, which I've already found out to be a magic number, what will happen is that the string will suddenly behave differently, dramatically. And that's because it wants to ring at this frequency. Let's start the video again and see what happens if we increase the frequency again. So this is 11 hertz. Let's move it up. This is going up to something like 15 or 16 hertz, right? Let's see. Right here. So we've changed now, we're moving faster, still at the same amplitude on the woofer. Now let's go to 22 hertz and see what happens. We'll have two large excursions, 2 points where it's moving much more than the woofer is, on either side of that point where it's stopped. But this happens naturally. I haven't done anything to the string to make this happen other than to put in the frequency where this mode wants to vibrate. So let's start the string really stops vibrating in those 2 sections you can see there in the middle. And we have these 3 areas where the string is vibrating up and down more than the amplitude that we're putting in from the woofer. Behave here again. Now we have 3 points on the string where it's not vibrating, and 4 points where it's vibrating more than the amount of energy that we're putting in, or the excursion that we're putting in. So this will keep happening as I go up in frequency. This is 44 hertz. If I multiply the original by 5, I get 55 hertz. And of course, you can see it's the same behavior as I keep going up and up.
دو تا، سه تا، 4 تا، 5 تا، 6 تا. این شکل مود ششمه.
We can zoom in on this and we'll its third mode of vibration. It's the combination of all those frequencies playing together.
خب ادامه بحث مود شیپ ها و فیلم هایی که مربوط به اون بود رو بریم ببینیم و
right now we have a small table which is mounted here. Tabletop. There are 3 models here. There are 3-story building model, 2-story building model, and 1-story building model. We are going to see here the basics of frequencies Resonance is the thing which shows us whenever the vibration frequency matches with the frequency of the structure, then there will be a resonance effect. In the sense, the vibration will be more and more vibration we will feel on the structure. So that is called a resonance effect. So let us start with the things. So I will. We have a motor fixed here, which will vibrate the table. Maybe a maximum displacement may be about 0.5 mm, but the frequency of vibration can be changed by controlling the knobs here. There is a control unit. So let us see how it is going to start. How it is vibrating. Started. Now slowly I am increasing the vibration frequency of this table by controlling the fine tuning knob. You can see already the 3-story building model is started.
در واقع این که الان داره نوسان 3 درجه آزادی بسازه یا همون حالا میشه گفت یه اسکلت 3 طبقه.
Let us see. I will try to increase the frequency of the shake table, the basic base plate. By increasing, you can see here the frequency about 2 or 3 hertz in between. So the actual frequency of this vibration can be measured by fixing a sensor as shown there. I am increasing the cycles per second of base plate. Whenever the frequency of this base plate, the shaking frequency of the base plate is matching with the natural frequency of this, it will start vibrating. Now it is exactly matched. The frequency, natural frequency of the visual building is matched with the vibrating frequency of this horizontal vibration frequency of this base plate. Now I am changing it.
در واقع با تغییر فرکانس‌ها از حالت غیر تشدید به حالت تشدید
not matching with the frequency of the vibration of the base plate. You can see here. Now the second building, two-story building on a base incorporated in the first part is moving the first one. So the frequency of that is approximately about 3 to 4 bars in that. You can see how much exactly it has. It's very different. Whereas this building and this building is not at all vibrating because that frequency is not getting matched with the frequency of this shake table. Now I am changing, I will increase the vibrating frequency of this shake table to the air mode by opening the knob. You can see the first building model will get now start vibrating.
در واقع میشه گفت اینجا انواع شکل مودها برای یک سیستم 1 درجه آزادی، 2 درجه آزادی، 3 درجه آزادی میشه خیلی راحت به وجود بیاد. الان برای 1 درجه آزادی سیستم به حالت رزونانس یعنی یه جورای آخرش اگه ادامه دار باشه مثل همون فیلمی که ایشون داریم یک کل معلقی بود که باد بهش می‌خورد و نوسان به آخر سر کلپس شد و ویران شد. برای ایران اتفاق بود. چه اتفاق میفته؟ این چه اتفاق میفته بر اساس نشون دادم گفتم نیازه که یه مورد بیشتر بر اساس این نمودار آخرش مبحث به نام فرکچر بوده. پس بنابراین وقتی که این نوسانات و فرکانس ها میرن به سمت تشدید دیگه سیستم از حالت الاستیک محدوده الاستیک خارج میشه و به حالت نکینگ و در نهایت فرکچر میرسه، یعنی گلویی شدن و در نهایت شدن.
So that you can make out the resonance effect in the sense whenever the vibrating frequency is getting matched with the natural frequency, the vibration effect or the displacement of that particular structure will be more. That is called as resonance. If that what happens when an earthquake happens, if the frequency content of the earthquake is matched with the frequency of any of the frequency of the building.
در واقع هم بحث فرکانس ها وارد شدن به پدیده رزونانس و تشدید توضیح میده. خب بریم بعدی. این هم که توضیح دادیم. تجمع ذرات هست، جایی که جابجایی صفر. الان میشه اینجا حس کرد. ببینید فرکانس دوم رو حالا ببینید. تا در واقع گره رو فرق داره با حالت فرق داریم. این در واقع یک تیر مولتی اسپن هست. مولتی اسپن ها یعنی چند تکیه کنه. توجه کنید به دو تا نخ داریم. یه نخ اینجا هست. یعنی یه جورایی میشه گفت با افزایش فرکانس ها، یعنی بالا بردن فرکانس ها یا به عبارتی با افزایش شکل مودها، یعنی بالا رفتن شکل مودها، تعداد نودها و گره ها هم به هم بیشتر خواهد شد. خب به دلیل کمبود وقت